I'm very happy to be here. Hello. I'll talk today about some of the custom ETL modules that we've built for the Florida Public Archaeology Network. Um, and I'll just get into it. I've been involved with Arches for a while. I work as a geospatial software developer through my own company, Legion GIS, and got into GIS through archaeology back in 2012, 2011. And in 2014, started working with Arches. And these are a few of the main projects I've worked on for different Arches implementations. And today I'll be talking about the Heritage Monitoring Scouts program that at FPAN. Outside of Arches, I more recently developed and maintained this crowdsourcing website for georeferencing sandboard maps called oldinsurancemaps.net, and have gotten more involved with open historical map and OpenStreetMap communities, as well as some other kind of librarian and coding GIS work. So I was looking back through and figured out where we first got connected to FPAN in 2017. I went with Dennis and Annabelle, Allison, and David to the CAA, Computational Applications and Archaeology in Atlanta. And Becky and Kevin from FPAN attended this workshop, and afterwards were like, hey, we have this HMS, we have this monitoring program that we've been doing for a few years. We're interested in kind of moving it into a larger, more comprehensive database setup, and interested in Arches. So that's where how I got involved with working with FPAN, and it's been great since. There's people on this call who know much more about the history of FPAN than I, but it's a really wonderful public archaeology program across the whole state of Florida, and not something every state has. So the Heritage Monitoring Scouts program is what I'll be talking about today. It's a participatory archaeological site monitoring project, essentially. And one thing I wanted to point out right away is that the Arches system we've built, it really accommodates two different types of users. But they do the same thing. They record condition assessments on archaeological sites. But there's one side which is for scouts, who are community members who have completed a training course. And then on the other hand, there's land managers, is what we call people who have accounts that are like for employees and staff at organizations across the state, like state parks, conservation areas, et cetera. So there's kind of two use cases doing the same thing in this system. Today, what I'm going to talk about is these two kind of bespoke ETL modules that I've built to support some of the needs for this Arches implementation. These really, they're the latest versions of operations we've had basically since the beginning that accomplish these two operations. Long before the ETL manager or bulk data manager was part of Arches, we had some other scripts, and at one point a QGIS plugin that I made for this FMSF thing side of things. So when the ETL manager came along, I kind of consolidated and moved things into this Arches pattern. And if anyone wants to look at the code, well, there's a link. I even queued up the chat. There we go. Takes a while to navigate Zoom. Okay. Anyway, if you're interested in looking at the code for these particular modules, that's where it is. I'll first talk about the second one here, this management area importer, and then go to the other one. So this is also kind of a bait and switch, because this does not actually load Arches in resource instances. I use this ETL module to load entries into a custom Django table, like a model, custom Django model that I made. It's underneath a handful of other operations. It's necessary for some operations, as you'll see, but where we would do some backend things or some sort of other import processes. Once the ETL module came along, I decided to wrap the ability to load these in through the module. So management areas store the boundaries of state parks, conservation areas, etc. You can see the table here. This is in the kind of the main Django backend. And they're used in the application to drive some spatial joins that are important. They are used to grant land managers access to archaeological sites only on their parks, for example. And moving that system into the ETL module made basically a nice front end for Cassie to use to upload new management areas. So one is to get that one out of the way because it's not making Arch's resources, but it is a helpful way to kind of use Arch's patterns to load in our custom models, objects, essentially. So I'll talk a bit more now about this FMSF data importer. To understand why we have it, it's important to understand the database structure of the HMS database. So we have 4 resource models, and 3 of these are actually effectively read-only, like I wrote here. So archaeological sites, historic cemeteries, and historic structures. We don't create any of those resources in Arches. We don't edit any of those resources in Arches. What we do in Arches is create that 4th one. We create instances of the scout report and then attach it to archaeological sites, cemeteries that are already in the system. So all of those resources that get loaded in for those 3 resource models, those come straight from the statewide database of cultural heritage sites, the Florida Master Site file, as a FMSF. And you can see here, the FMSF has a few other categories of resources. So there's bridges in the system. There's historic districts, landscapes, and linear features. We don't import those. We're only concerned with the archaeological sites, structures, and cemeteries. So this is this is kind of the way data comes from the FMSF and gets into Arches through that ETL process. Cassie does this or requests these exports from FMSF. So you can get shape files that have the boundaries or the points or polygons for each of the different resource types. And then you can also export the tabular data, which comes in an access database that's called Santa Claus. It's festive. And that has a few other tabular pieces of tabular information that we also need when we're putting this into Arches. And then this is kind of what Cassie does, is then zip these in. So the shapefile for sites and the exported tabular data for sites gets made into a zip file. And the FMSF data importer takes one of those zip files, one per resource type. So you can see on the right, this is kind of the configuration setup, how I've set up that module. So you would upload one of these zip files and then determine what set what resource type it is. There's a few other optional properties you can set for the load. And then when you click run, this is what happens kind of behind the scenes. And again, this is within the importer module or base import module structure that Arches provides. So there's this run sequence method that I made that kind of wraps up all of these other operations. Validate the data that comes in from the shapefile and the CSV, read the features from the shapefile, make Arches tiles for each feature. And then these next two, the load staging table and then writing data from the staging table into Arches, those are Arches patterns that are already used in other ETL systems. So it's kind of following the steps of some of the examples. And then finally, there's the spatial join operation, which uses those management areas that I showed earlier and attaches attributes from them to each resource instance as it gets loaded in. For example, if one of the archaeological sites is within a park, within a state park, then it's going to get the name of that state park and a few other attributes that are derived from the spatial join against that management areas table. Okay, so I was thinking we could do this. About how much time do we have? It won't take long, really.
I think we're good on time if you want to take it.
Sure. So, okay, sounds good. So this is just to, it'll only take a second really, but this is like a local dev installation of the database. And so I've filtered only historic cemeteries, and you can see there's 25 in this local Arches instance right now. We head over here and select the ETL module. And again, this is a lot of instructions essentially for Cassie or for myself to remember. And then select a file. We have a cemetery file. So this is the list of, this is what was zipped up in there. I'll set this to be cemeteries. And then this truncate option I added, it's very useful for development because it's just nice to only add a few. So I'll say we're going to add 100 of these sites. I think there's like 3 or 4,000. There's a few thousand in this export, and I can't remember how many. Great. So then we'll begin export or import. So there, as those different steps are completed, there's kind of status updates. So this page, this Arches page updates automatically and will give new statuses kind of throughout the import process. And so right now we're at this generating load data stage. So now we're in the indexing stage, and now it's done. So you can see there's a bunch of extra load details. I kind of just jam extra info into one of the reporter options, like the status that's in the table for the uploads. And it's not like really well formatted, but this is it gives some feedback if there was an error. So if we go back to this page and reload it, you should see 125 now of those cemeteries. We go look at one. Fowler burial, etc. If this were in a state park, it would have, the spatial join would have added the state park name and a couple other pieces of information under this management tab. But yeah, so that's pretty much it. The only other detail I wanted to mention is that we have this extra set of filtering for historic structures because there's, tens of thousands of historic structures in the FMSF database, and we didn't want to add all of those into the HMS system at all. So we made a few. We kind of have this filter system that removes any that are marked as destroyed, includes any that are lighthouses or are within those management areas that I was talking about earlier. So the historic structure import adds an extra step, which actually takes a lot of time because it's kind of a spatial intersection to filter out what not to load in. But that was the only other thing I wanted to mention. So yeah, happy for questions. However, Maddie wants to do this. You can the website itself is you have to be part of the you have to be a scout to log in and actually see things. But there's a little information on the front page, and you can find the code base on GitHub. And also special thanks to Cassie, who's on the call and dealt with has a lot of patience because there's been a lot of snafus along the way over the years. So yeah, that's all for me.
Thank you so much, Adam. This is awesome. Would anyone like to ask any questions?
I've got a couple questions if nobody else wants
Yeah.
to go first.
Yeah, go ahead.
So Adam, I want to say thank you so much for like sharing this. You actually gave us a really good tour of this a couple of years ago, and Sorry, I'm really pink right now. I want to ask, first of all, basically, like, have things like drastically changed over the last couple of years? And also, I think we asked you at the time, like, what does sort of mobile data collection look like for this process? Are you basically just sort of pointing a smartphone's browser at at your Arches instance, or like, is there more software that's involved in that? So, thank you.
Yes, good question. So the first question, in the last couple of years, I've made maybe a tweak or two to how well, the spatial join used to be used to actually join against there's FPAN regions and counties. And then Cassie pointed out just last year that all of the information is in one of the IDs in the actual site ID. So I moved that into just a lookup table based on the first two letters of the site ID. So a few changes, and then I've updated the code base to Arches 7.6. There weren't a lot of changes that I had to make to within the ETL, those ETL modules, a little bit because I think I had changed one of the templates and things like that. So overall, not too much in the last couple of years that I can recall. I also don't know exactly what the status was a couple of years ago. As for mobile data collection, this is well, the mobile data collector app was kind of what Becky and Kevin really wanted in 2017, and we never really got it going. And so I think the FPANers on this call would have more to say about that. But I think when folks go out, well, honestly, when folks go out in the field, I don't know, does Emily or Cassie mind jumping in?
we use we use paper forms and have to fill our instance does not work in the field at all. You can't even load it on a smartphone. And Emily Jane, if you want to say anything else, I mean, we essentially I couldn't get it to load from my phone in my office. It only loads on a computer.
Oh, I can get it to load on a phone, but like only with enough patience to like upload photos from my phone so I don't have to transfer it. Because trying to fill out the paper, yeah, it doesn't fit the phone screen is really the problem. Um so yeah, that's our dream is to be able to do it in the field, but we appreciate the constraints and we love what we have. So
Yes. Well, and I will say too, the formatting is one issue, but the other major issue too for us is that we go to some really, really rural places. So even relying on internet access is a huge problem for us because we cannot rely on that. So even if we had something that would work, in a city, we go to some places that we barely get cell service. So that's another major obstacle for us when it comes to using it in the field is we need something that has delayed upload and things like that. So that's one of our biggest obstacles. We do things, obviously, we have structures and things like that, but some of the places that we go are swampy and we use airboats and things like that to go to the places that we go, as Emily Jane knows. And sometimes we use boats. We go to underwater sites, so we're out in the middle of the ocean sometimes, and so we need something that has the ability to upload after the fact. That can't use internet. So that's one of our biggest obstacles as well, aside from the issues of just loading and viewing on a phone or something like that.
Thanks.
One of our current thoughts is just a custom workflow, like a custom workflow that would be, have responsive formatting, and it's just something we haven't gotten to fund and get done yet.
I'll
Maybe.
share one thing that Farallon has worked on that's not necessarily in the spirit of open source, but leveraging ArcGIS Online or ArcGIS Enterprise with Survey 123 or field maps. And we built a custom importer that could take advantage of that kind of like form-based paradigm and the offline maps that are or offline access that's capable there, just as a place to collect the data and then use the bulk importer to import that and map it appropriately to your Arches models, um, as kind of a hybrid thing.
Yeah, I think I'll also chime in there as well in regards to other applications um, outside of the Arches sphere. There are folks using other Arches projects that are using other applications such as Open Data Kit for data collection. And I just spoke to somebody who's interested in using QField. So that's the QGIS data collection application. And as a reminder for everyone, there as Peter mentioned, but also that there are applications to connect that provide links between Arches and QGIS and Arches and ArcGIS.
Thanks, everyone. I think we'll jump over to Emily's presentation.
Great. Let me share my screen.
Sure.
Okay. Can everyone see that? Great.
Yes.
So I'll introduce myself again. Hello, I'm Emily Cunningham. I'm a professional fellow on the Arches project team at the GCI. And today I'm going to talk through some of the ETL work we do here on the Arches project team. So I'm going to talk about Arches for Reference and Sample Collections, which is also known as RaSColls. And this is an application purpose-built for managing data and sharing resources of heritage science reference and sample collections. RaSColls is currently under development, and we're working closely with our colleagues in the GCI Science Department to create an instance that works for their reference, sample, and building materials collections, while also thinking big picture about the needs of the field and how other institutions may use RaSColls for their own collections. Currently, we're focused on the GCI reference collection, which includes artist materials like pigments, dyes, resins, waxes. It's a pretty amazing collection of objects. But migrating a legacy dataset into Arches is no small feat. As we learned today, ETL stands for extract, transform, load, and this is the three-part process. You pull data out of one system, reshape it to fit a new model, and then load it into a new destination. And for RaSColls, this means extracting data from the current FileMaker Pro database, which of course is a relational database, transforming it to align with the RaSColls resource models, and then loading it into Arches. And our team, which includes Annabelle, as well as Eric Kanza, who is usually on these calls but was not able to join today, the team has been doing this work since 2024. And so there are three main things that support this ETL work for RaSColls in particular. We do our data preparation primarily in OpenRefine. This is where we clean, reformat, and augment the raw data. This is what I will focus on most because this is where I'm the most hands-on. But we also have a streamlined Docker-based install process for RaSColls, and this allows us to keep pace with the rapid parallel development of the application itself. Instead of using the bulk data manager, we use a custom Python and SQL script to load the data into Arches, and I'll touch on that a little bit more at the end. Both the Docker install and our custom loading script exist for the same kind of purpose. Because RaSColls itself is still being actively developed, our tools need to kind of allow us to rebuild, test, and adjust very quickly. Our data transformations can happen in batches. We often do one field or group of fields at a time, but we really want to see those changes reflected quickly in the data in the Arches instance itself. That way our GCI science colleagues can test the functionality and give us feedback. So OpenRefine, for anyone who hasn't used it, it's an amazing free open source software for cleaning, transforming, and enriching messy data. And a few things make it well suited for this specific kind of migration work. It lets you get really granular with the data that you're looking at. You can facet and filter down to the exact rows that you want to address. There are built-in clustering algorithms that help with deduplication. You can enrich your data set by calling out to external sources like Getty vocabs, Wikidata, or really anything with an API. And it runs on a local web server, which allows you to use your own machine rather than the cloud, which is great if your data requires some privacy. And every operation is recorded, so the whole process is auditable and reproducible. And lastly, I'll note that it is best for data sets under 1 million rows. Anything over that, you may want to look into a different programmatic approach. So for the RaSColls migration, so far we have performed over 5,400 individual edit operations in OpenRefine. Most of these are bulk edits that are applied across many rows at once, but there are still plenty of one-off manual edits to help fix the edge cases that we come across. A lot of the work has to do with dealing with information that's lived in loose free text notes fields and turning those into a series of fields that adhere to the CDOC CRM. And that, of course, makes the data machine readable and queryable. So with OpenRefine, more specifically, we can use APIs to enrich the data programmatically. So we have added geonames identifiers for over 1,200 unique places, as well as GBIF data, and that's the Global Biodiversity Information Facility. We've added over 500 unique biological taxa. Using OpenRefine, we can standardize terminologies. Many of the text fields many of the fields were converted into controlled vocabularies. So we could extract a term list from the data and then standardize the terms and align them with authority-controlled vocabularies. OpenRefine can also be used to clean named entities like people and organizations. We're able to use the clustering tool. It'll scan an entire column to find different spellings or formattings of the same name, and then you can normalize the spelling in one batch edit for all of those records. And of course, you can easily normalize other types of data, including dates. And so here is an example of a pretty straightforward transformation. This free text field was originally labeled mass or volume, and it includes all kinds of measurements, mass and volume, but also height, width, sometimes even counts of objects like sheets of photo paper or bottles of paint. So we separate the value from the unit because these need to be distinct fields so that they can be machine readable. Something like 100 milliliters becomes a numeric value of 100 and a unit of milliliter. In OpenRefine, this kind of split is very straightforward. You can use a regex operation that grabs the digits, including the decimal points, from the very start of the string, and then it'll stop once it hits a space or a letter. It'll put that into a new value column, and then what's left becomes the unit. It's a fairly clean approach, but there's always edge cases if someone wrote something in a different format or if there's a typo. So it's important even with these easy transformations to do some manual review and hand editing to catch what the programmatic parsing cannot. We also used the unit to determine the measurement type. Is this a mass, a volume, a length, a count? And we created controlled lists for measurement units and types and aligned the strings with an authority vocabulary. Another important practice throughout this part of the ETL process is that we always try to keep the original untouched values alongside the clean ones so that we can do side-by-side quality checks throughout the process. Now I will show you an example that was less straightforward. In this case, several free text fields were used to capture a variety of information, and it is much more difficult to parse. So here you can see these are items in the collection that are mixtures, and that means the scientists prepared them themselves. It could be like a pigment mixed with a binder and a solvent in a specific ratio, and a mixture can have up to 4 separate components. But all of that information was captured across these 4 different free text fields, including formulation, pigment, component 1, and component 2. And within those fields, we're seeing details for individual components, like the material name, the type, the measurement, along with mixture level information like technique, ratio, and notes. So there were 2 parts to this parsing. First, figuring out which piece of information belonged to which component, but also then breaking each component into its own set of structured fields. And the way it panned out was about 7 fields per component. So with that in mind, this is how 4 fields essentially became 36, at least in the way that we're looking at the data. And again, this is 4 repeated sets of the same component branch. And there's no one item here that uses all 36 fields, but you can see how much work it can take to parse out just a little bit of information when it's actually quite information rich. And the formatting here was inconsistent partially because the scientists doing this data entry were students or postdocs, and they were only with the GCI temporarily. And each person has their own note-taking style and data recording habits. So because of this, we had to use some different parsing techniques and really use those filtering and facets to look at specific records that kind of had the same structure and parse them out separately. It does require a lot of row by row editing in some cases for those edge cases, and it's slower work. The same principle applies from the last example. Always keep the original data visible for comparison, and we can't trust that any automation will be perfect. Beyond cleaning what's already there, we also enriched the data set. So I mentioned those geo names. Here you can see the URIs and the labels are brought in on the country, state or region, and city level. And what's great about this is it's not just a place name, it's a stable linked identifier tied to an established geographic data. And this same idea here applied to the wood samples specifically. This is where the GBIF URIs come in. And here we can see we've also brought in the vernacular name and the canonical name. That way we can kind of have a better idea of what exactly we're talking about. And so why does the enrichment of our data matter? It's because every time we tie our data to a shared vocabulary or identifier system, instead of a free text label, we're linking it to an existing concept rather than reinventing our own version of it. So right now, RaSColls connects to geonames, GBIF, the Getty AAT, and QUDT for measurements. And because these are identifier systems that are used widely across cultural heritage and scientific data, this sets us up better for future interoperability. So once the data is transformed, we can load it into Arches, and this is really Eric Kanza's specialty, so I will keep it high level. But he uses a set of Python and SQL scripts along with the Arches relational views feature to move the data into Arches. And this custom approach is used instead of the bulk data manager because it gives us flexibility that we need to manage a project that is still evolving. Eric is able to isolate and tweak just one part of the script without having to redo the entire load, which saves a lot of time. And he can build it up incrementally as we add new fields or maybe come across some edge cases. And he can rerun it as many times as needed. It's also great for establishing relationships between entities and working with JSON formatted fields. So ultimately, it's a structured way that's easy to debug, and much of it can be repurposed for other RaSColls datasets in the future. That is the end of my presentation. I'm happy to answer any questions about transforming data. I can also attempt to answer questions about Eric's script, which is very interesting. Annabelle may be able to jump in as well. I'll add a link to Eric's script in the chat. And if there's anything that we cannot answer, or if a question comes up later down the line, I encourage you to use the forum. And Eric is very active there. He will see your question and he would love to discuss his methods.
Thank you, Emily. Yay. Any questions for Emily?
I have a quick question, Emily. I'm not sure the size of the data set and whether the size of the data set would warrant this, but I've been reading about other ETL processes with provenance data, especially, and the application of natural language processing to help with the kind of transformations and annotations of the data as you're doing. And I was wondering if you've been exploring that or maybe applying that in any way here, or if it's just not a good fit for what you're doing for the data set.
It's not something we've looked into yet, but that doesn't mean that we shouldn't. In fact, I think it's something we should. Yeah. Do you have experience?
Not direct, but I've been following a project out of, I think it's out of Germany, that I can send you some articles about, and their experiments doing this for provenance data.
I'd be interested to read that.
And I think that's maybe something that we can also pass over to our colleagues who, for those of you who are aware of this other Arches implementation at the Getty Research Institute, which has about 4 million records for provenance research, art provenance research. So, and they're in the process of, a data editing process. They're in a data editing process at the moment.
If there are no other questions, we can jump to Tris and then Evans. Maybe we can fit you both in a couple minutes. If not, we could also, you could share at the next meeting on September 10th if you're available then. Tris?
Sure. Okay, actually, I'm gonna make this super, super quick, but basically, I'm just gonna drop a repo in the link in the chat. Basically, we were working on this a couple of years ago, where we needed to sort of like assemble resource to resource relationships, like, within a Python script that uses pandas. This is a very, very simple, there's minimal like sort of geospatial processing. It's just like lat longs. So it's a much smaller and, demo project rather than like the complicated, like decade-long stuff that Adam outlined. But like, I just want to put that in there. And now I'm going to hand it over to Evan so he can tell his story. Thank you.
Thank you, Tris. For me, I'll make it super quick too. At first, we began with the build data manager with the Portugal CSV ETL module to import the data. The data we have are from legacy system about cultural heritage and archaeological data, and they are legacy systems, so there are a bunch of database, a bunch of kind of relational database, and none of them talk together. So we tried at first with the data manager, but we stumbled on the limitation that was talked think April last year, because we have models with more than one level, so we can't map data that is too deep with the single CSV. So we switched to the CLI with the pure CSV mode that existed before. We had a little issue with it, but it was normal because we didn't provide the tile ID and the parent tile ID, which now we provide, and we had to do a little fix. We should do a PR for that if it is needed, because for us it's only a one-shot import, and after that we won't use it anymore. So we'll see if it would be useful for the community to provide this fix. It's not a big fix. We just reuse everything of the logic that was there. It's just like some tweaks here and there to be able to pass the data through it. The ETL module, we look into it, but at the beginning we thought it was too much coupling for the code, and since it's a one shot, we had to do. It was not ideal to develop a module for that. So instead, we used a more classical approach. So we used Daxter for the data pipeline and OpenRefine, as Emily just presented, for the same use case. So we use the same thing, the same call, the geoname, and all of that. And in the end, the SQL import, at the beginning, we thought we had to learn all of the Arches data model to be able to use it, but maybe it was the documentation that misled us to understand that, because 28th of May, there was a presentation and we understood the generation of the views and starting with the views and all of that. So we'll keep it in the back pocket for now if the CSV cause problem like for the performance, something like that, because we don't have million of rows to manage to import. So maybe which back to a script import at that moment. So that was pretty much all I had to tell about the kind of informal story of our progress when we began the migration of the data between the legacy system and Arches project.
Great. Thank you. Any questions for Tris or Evans? Is your code online anywhere, Evans?
I need to work on that. We are in the GitHub, but it's a private repo for now. But we need to plan because it's more like it's a public client. We could work around some of things, but we just need to do cleanup to be sure to share it more easily than all mixed up with a custom Arches instance. So it's in the notes to be able to provide that eventually.
Yeah, great. Well, thank you, Tris and Evans, for jumping in and sharing. And big thanks to Adam and to Emily for your amazing presentations. It'll be really great to have the recording too to look back at.